Yeah, afternoon, folks. This time around, I'm touching on momentum and mathematics, mechanics options. I hope you find this clip educating. Let's have a look. Um, right. Momentum is a vector quantity, so we might be interested in knowing the formula denoted by P is a product of mass and velocity. And when we find this product, I mean, it gives us units Newton second or kilogram per meter squared. But one other thing to note is momentum is conserved. So in other words, if I've got two objects, m1 with an initial speed u1 plus an object m2 and initial speed u2, whatever that happens, if there's collision, this will be equal to, because momentum is conserved, m1 v1 plus m2 V2. So if we have that in mind, I'm sure we'll be able to play around with these problems. So have a look at the first question we have. Um, Particles P of mass P and Q of mass 0.2 are free to move on a smooth horizontal plane. P is projected with speed so we've got particle P, and normally we model them as balls or objects like that. I've got its mass is m kilograms. It's projected with a speed 2 meters per second towards Q. Q is stationary. So Q, we know its mass is 0.2. But here we are told it's stationary, so its speed is 0 meters per second. Then after the collision, definitely they are going to collide. After the collision, P and Q move in opposite directions with speed. It looks like P bounces back, so we have P going in the opposite direction. So it's now going backwards with an unknown speed. We don't know, after the collision, P and Q move in opposite direction with speeds of 0.5 hours. So here we have got 0.5 meter per second, and Q will be going in this direction with a speed 1 meter per second. So we're interested in finding the value of m, and this is what we'll do. We'll try and use our conservation equation to say before collision, we have got 2 multiplied by m, because that's our velocity. So it gives us 2m plus there is going to be 0, because we're multiplying this mass by 0. That's 0.2 by 0. 0.2 by 0. Okay. 0.2 by 0. So it will give us definitely a 0 there equal to, and after collision, direction is important because it's a vector quantity. It's now going backwards, so it's going to be minus 0.5 multiplied by m, the unknown, which was the mass, plus, because we're in the same direction, we're treating right as positive. So that's 0.2 multiplied by 1. And now when I simplify, I'm going to transpose this with a linear equation, which gives me 2.5 m being equal to 0.2. I need my calculator here. First, I'll divide both sides by 0.2. Let's check if I can pick my calculator. It can help me to do these simple calculations. Let me bring it this side to say I've got, let's see, clear is 0.2 divided by 2.5. Try and clear here. Because I had 2.5 m equal to 0.2, so it's divided by 2.5. Let me try and bring back the calculator. So it's going to be 0.2 divided by 2.5, giving us 0.08. So the mass m is going to be equal to 0.08 kilograms. That was it on the first problem. Let me have a look at what we have next. There's another question. Two particles, P and Q of mass is 0.2, 0.5, are at rest on a smooth horizontal plane. P is projected towards Q with speed 2 meters per second. So they're both at rest. So we know P is the one that was projected, and we are given its speed is 2. And P's mass is 0.2 kilograms towards Q. But remember, Q is at rest, so its speed is 0. But its mass is known to be 0.5 kilograms. So we are saying after the collision, uh, or we just want momentum of P. So momentum of P is just mv, like we calculated earlier, which is mass that's 0.2 multiplied by the speed 2. So we need our calculator there. Say 0.2 multiplied by 2 gives us 0.4. So here we have our momentum is 0.4 Newton second. Then moving to B part, after the collision, P continues to move in the same direction. So P continues to move in the same direction. P, um, let's check. P continues in the same direction. So P was going to the right, and then after collision, it continues in the same direction. So we are assuming P will continue. Its mass, we have it above. P's mass is 0.2. And what happens to Q? Uh, Q continues in the same direction with speed 0.3 meters per second. Find the speed of Q. We assume Q will begin to move. So if it happens that Q is also moving in this direction, but we had mass of Q. Q is 0.5 kilograms, 0.5 kilograms. So this is kilograms. So our interest is to find the, whatever we do, we know before collision, the total momentum was 0.4 because Q was stationary. So we are going to come and say equal to, so everything was 0.4 before collision. Then after collision, we have 0.2 multiplied by 0.3, and there is 0.5 V. So when we transpose, it's going to be 0.4 minus 0.2 times 0.3, or equal to 0.5 V. So let's try and use our calculators. I'm going to say 0.2 multiplied by 0.3 gives us 0.06, minus 4 minus 0.4, 0.4, it gives us 0.34. So here we know 0.5 V is equal to 0.34. So we divide both sides by 0.5 for us to get the value of V. So in doing so, we are going to divide here by 0.5, 0.5. Yet cancel, so our V will be equal to, bringing my calculator back, I will divide here by 0.5 and it will give me 0.68. So here we have 0.68 meter per second. So don't worry about my calculator which is showing a negative. I was just trying to simplify the calculations so that it's quick. I think that was it from the basic concepts around momentum. I hope you found it informing. Thank you.